Hello all CMA final students, welcome to this SEM marathon. Our next topic is business forecasting models. Before we get into this topic, a small request from my end is most of the students are watching the videos, but they are not liking it or sharing it to their friends. So my sincere request to all the students is to share these videos to most number of students, that is to your friends, so that my efforts will get the results, desired results. I hope you keep this in your mind, and not only that, when you share to most number of students, I'm going to get their feedback also. Already I'm getting feedback from the students also. So that will motivate me to do more quality videos. Right? So I hope you all are appreciating my work, because every topic I'm trying to extract the most for the students. So let's hope that students will encourage me in future to do more number of videos, so that help the larger student community in future. So let's start now. So this particular topic is, as you all know, is a very easy topic. Little bit of mathematics is also required. Mathematical knowledge is also required here. So in examination, the last question generally covers business forecasting model topic. So in this you have time series and regression questions. So they have been asking from a time series topic only. Probably they might ask from regression this time. So we hope that they might ask from regression. Anyhow, we are going to revise both the topics. So what exactly is forecasting in business? We tend to forecast various variables. It could be sales, it could be output, or it could be profit. Because what is going to be my profit, or what is going to be my sales in future is an unknown variable. In order to estimate those, we use these models. Now, forecast is basically a prediction of uncertain future. What is forecasting? Forecasting is generally the process of estimating. The process of estimating is only called as forecasting. Now there are two methods. One is qualitative methods, the other one is quantitative methods. This is how they have segregated in our material. So qualitative does not involve any calculations, whereas quantitative involves calculations. So qualitative methods are opinion based. These all are opinion based. So these are the various methods which they have mentioned in the material. These all are the qualitative methods in order to extract the data and also to forecast the data, to estimate the data. So these all are various techniques. So from all these techniques, what we are going to do is we are going to get the input either in the form of questionnaires or in the form of indicators or in the form of opinions from the managers, or in the form of a survey conducted on customers. So using these methods, they are going to estimate, get the input from which they will estimate. So these are qualitative methods. Now what is more important in this chapter is quantitative methods, which covers two. One is regression, the other one is time series. So mostly they are covering from time series, so probably they might cover from regression. So first we'll cover regression, then we'll move to time series. So regression equations are nothing but the straight lines. So in this again, the first one, so what we do under regression is we try to formulate the relationship between variables in the form of mathematical equations. Under this, what we do is, in order to forecast the figures, first what we will do is, we try to establish a relationship between the variables. Say for example, price and sales. These are two variables. Now what I want to do is, I want to estimate what is the demand if there is a change in price. What is the change in demand with respect to change in price? So now in order to forecast this, I need past figures. So generally here in regression, to form the equation, generally we use the past data of price and demand only. So these two relationship is derived by an equation. Okay, first we derive an equation, then from the equation only we are going to forecast the figures of demand from based on the price. So this is what we are going to do. So under regression, basically we are going to formulate equations to explain the relationship between two variables. So here there can be two types of regression. One is single linear regression, other one is multiple linear regression. What is single linear regression is, here we can say one is simple, sorry, I use the word single here. One is simple linear regression, other one is multiple linear regression. So whenever we have two variables, bivariate data, that is two variables, so that is 1 to 1. So earlier the example price and demand, these are 1 to 1. So here we have two variables. So when you have more than two variables, then we can call it as multi linear regression equations. So simple linear regression, when we say that it is simple linear regression, when you have 1 to 1, so two variables you have, now we have to establish the relationship. So like for example, age, weight, what is the relationship between age and weight? So that is 1 is to 1. Or exports and imports relationship, or price demand relationship, exports and imports, age, weight relationship. So this relationship we are going to establish in the form of an equation which is called as regression line, simple linear regression, SLR. So when we have 1 is to many variables here, see now we have only one variable here, that is salary, and the salary depends on many factors like age, experience and qualifications. So this is called as multi-variable equation. So here what is happening is, we have 1 is to many here. So here we have to forecast what is going to be the salary according to the different variables here. So here if you see, you can see three variables are there. So that is the difference here between these two, simple linear regression, other one is multiple linear regression. So when we call it a simple linear regression, bivariate data you have to two variables. So 1 is to 1. Whereas multiple you have more than 2. So that is what first you need to identify. Now first let us cover simple linear regression. So how to find out, how to get the values here using a equation, that is what we need to understand. So here this is the equation. Since we are talking about two variables here, two variables can be, one can be named as x, other one can be named as y, or this can be named as y, that can be named as x, right? So therefore we will have two types of equations, right? Now if I take price, if I try to derive what is the demand for various prices now, so price I will assume it as x and demand I will assume it as y, or I can assume price demand as x and price as y. So that means we can have two types of equations. So type 1 is y on x type here. So what is the equation? That is y is equal to a plus bx. So here what we need to do is, we need to get the values of we need to forecast the values, no? So this only I have to forecast y. So y is called as the dependent variable and x is called as the independent. So here price is the independent variable and demand is the dependent variable. So we have to form this equation, right? So to form the equation, definitely we require a value and b values. So we have to calculate a value and b value. But if you assume otherwise, price as y and demand as x, then it will become x on y type. For that equation is x is equal to a plus by. Interchange. So these two equations will look like a straight lines only, straight line equations. So they will look like this, these equations. Okay, right now. So what we are doing is, first of all, we are establishing a relationship between two variables in the form of an equation. Then if you substitute in that equation the inputs, that is, if you give price, then you will get what? Demand. But the thing is, to get the equation we require a value and b value. Yes. So first one is type 1, y on x type. First one is y on x type. So here we use x to get y. What we do is we use x to get y. So we will form this equation. So something like this, y is equal to a plus, assuming we got x value as 2. So I will get, sorry, this is b equation, no? So assume that you got a value is 2, b value is 5. Then y is equal to 2 plus 5x. Something like this I will get equation. Then based on x values I will get y values. So that is how we have to forecast the figures here. So that is what I have written here. Y is equal to a plus bx, that is y on x type. To find this equation we have to find the values of a and b using the values of x and y. So first we will find out a and b using the values of x and y in the given question. So see one example here. Sales is given, other one is advertisement is given. Now I want to forecast what is going to be my sales depending on advertisement. What is going to be my sales depending on what? Advertisement. Once again I am repeating. So these are two variables here. I am taking two variables, sales, the other one is advertisement. So I would like to find out what is going to be my sales. Now these are for last 5 to 1, 2, 3, 4, last 5 years. Now next year I would like to predict what is going to be my sales depending on what is my advertisement. So now here what we need to do to get these values, we need to first get a value and b value. Remember here capital Y, here capital Y represents forecasted value. Small y represents the actual values. Actual values is nothing but past data. Okay, whenever the data is given, now in the question they are going to give you sales data and advertisement data for last 5 years. Then they will ask you to forecast for next year. So naturally we require past data of sales and advertisement, no? Yes. So the past data of sales and advertisement, we'll take it as x and y. That is small x and small y. Yes. Now after that, to get the values of a and b, we use these equations, normal equations. Remember, these are very important. Using these two equations only, we will find out the values of a and b. Then we will form the equation. So how these equations are also very simple to remember here. Why these equations are required? To get the values of a and b. So first equation, let us see how we are getting. Y is equal to a plus bx. This is the regression line. Now what you do is apply summation on both sides. Summation on both sides. Then you will get summation y is equal to summation a plus summation bx. Okay, I am applying summation on both sides. Okay, then summation y is equal to summation a. How I can write summation a? Summation a is a plus a plus a plus a plus a. So that is NA. Okay. Then summation of bx, how I can write is b summation x. Bring out b outside, summation x. So this is how you should write. This is the first equation. So what we are going to do is, we are going to get the values of a and b using small y and small x only, the past data. So here, this is the first equation. So in this, what you need to do is, these values you should calculate now. Summation of y you should calculate, summation of x value you should calculate. Once you calculate those values, put it in this equation. First equation it will become. Then again same equation, y is equal to bx. Y is equal to a plus bx. Then now what you do is, multiply with x on both sides. Multiply with x. This one, first equation. Then it will become xy ax, then bx square. Okay, then apply summation on both sides. Summation on both sides. Again, summation xy is equal to summation of ax, summation of bx square. Now what you do is, take out a, b outside. So a summation x, then b summation x square. That's it. So this is the second equation. I hope you can easily remember this process to get the equations. So because to solve for a and b, you require these equations only. Okay, so how to get these equations also I have told you now. How to remember that logic. So we solve the above equations now to get the values of small a and b. Once we get these values, then we will write the regression equation. Y, that is capital Y is equal to a plus bx. With the what values, a value and b value, whatever we got above now by solving these two equations. Okay, we will get a value and b value, that you will substitute in this equation. Then you can get the equation. Now what you will do is, given x value, you can calculate y value. So we use this regression equation to find the value of y at given value of x. This is what we are going to do. So that is type 1, that is y on x type. Use x now to get y. So what we are doing is, we are using x as input to get y values. Similarly, if you assume now this one has x, that one has y, possibility is there. Okay, both are because one we are taking as independent, the other one we are taking as dependent. So these variables can change now. So what if it is x on y type, then use y to get x. So now the equation will be x is equal to, you are using y to get x, capital X is equal to a plus by. So apply the same procedure whatever I applied here also to get normal equations to solve for a and b. So here x is equal to a plus by. Now again same summation on both sides. Summation on both sides. Okay, summation x is equal to summation a plus b, summation of by. Then take out the summation outside. Here summation a is na. Summation by, how you can write? B summation y. Now this side again, second equation, how do you get? Capital X is equal to a plus by. First what you need to do is, multiply with y. Earlier we multiplied with x, no, because there the input was x. Here the input is what? Y. So that is the reason we should multiply with y this equation. Then it will become xy ay by square. Then apply summation on both sides. Then summation xy, summation ay, summation by square you will get. Then take out a outside. X summation of xy is equal to a summation y plus b summation y square. Simple. So again, these are the two normal equations for x on y type. Now solve these two equations, you will get a value and b value, then form the regression line. From that you can forecast the values. Right students? Yes. So this is the first type. Okay. Now very simple, as you might have understood the logic here. What we are doing is, in this, to forecast the values, first what we are doing is, we will try to understand what is the correlation between those two variables. What is the correlation? Okay. First, once we get the correlation, then we measure the relationship between x and y in terms of an equation. Okay, we require values, no, not just the relationship, whether they have positive relation or negative relation. That is called as correlation. Apart from correlation, we require even values also, no. So to get the values, what we need to do is, we need to, so now what I will do is, if I take past values, x value and y value, this I will take it as x, this I will take it as y. So what I am doing is now I will plot the figures, x value and y value. What I will do is x value separately I will plot and y value also separately I will plot. Okay, assume you are getting like this. So now what I need to do is I need to I need to get an equation. This is only called as regression equation, which will be basically regression equation is the average of the average of what? The average of our x and y figures only. Our regression line represents the average of our x and y. So once we find out what is this mathematical equation, then we are getting the forecasted values. Right? Now, that is what is the logic of this formulas. Now to get this, what is now you need to know what is the interpretation of B. A is called as intercept here, B is called as the slope, A is called as the, now same I will use now diagram only. Earlier I was telling you that this is like our equation look, regression equation will look like. So this is x, this is y. So when x is equal to 0, whatever is the value of A, whatever is the value of y, yes, this is called as A. Okay, this is called as the intercept. What is intercept? When x is equal to 0, what is the value of A? Starting point here for the equation. Now next one is slope. So what is the change in y value with respect to change in 1 unit of x? Okay, with respect to change in 1 unit of x, this is called as B, the slope. So we need to calculate this A value and B value only. So whenever you are forming a regression line, we require B value and A value. What is the meaning of A is called as intercept. Okay, what is intercept? When x is equal to 0, what is the value of y? That is only called as intercept. And what is B? What is the change in y value with respect to change in x value? Yes, these are the two things what we need to get. To get this only we are forming those normal equations. Right? Now to get the same answer, to get the same forecasted values, there is another alternative also. Just now I was telling that that equation is nothing but deviations taking it from arithmetic mean of x and y. So instead of equation y is equal to a plus bx, we can also use this equation. Yes, y minus y bar is nothing but the mean. Y minus y bar is equal to b yx into x minus x bar. The same equation y is equal to a plus bx, that is first type. I am talking about the first type, y on x, can be written like this also. Y minus y bar is equal to byx into x minus x bar. How do I get byx? Summation of xy divided by summation x square, or correlation between y and x into standard deviation of y divided by standard deviation of x. Right? So generally in my regular class, I will tell, just now I was telling you that if you want to form an equation, you need to know the correlation between two variables or not. What is the meaning of correlation? How they move. Okay, yes. And not only that, and when I was earlier explaining, I was taking the line in between those the plottings, right? So now my actual values might deviate from my forecasted values now. So that I would like to minimize. So what is the standard deviation also I need to calculate here. So taking the deviations here, we are calculating the A values and B values here. This is the second one. So this is another way to calculate the x, y values. Okay, remember this students, because sometimes they might give you data like this. I will show you also in our CMA Institute material, they have given that. So y minus y bar is equal to byx into x minus x bar. How do you get byx? That is y on x type. Summation of xy divided by summation of x square, or correlation between y and x and y into standard deviation of y divided by standard deviation of x. Similarly now x on y type, how you can write x minus x bar into bxy into y minus y bar, and same formula xy is equal to summation of xy divided by x square. This is remaining same, but here correlation into standard deviation of x divided by standard deviation of y, because bxy, now first x then y, here first y standard deviation of y divided by standard deviation of x. This is correlation. So I will solve problem. Instead in MCQs they have given questions giving this data. Okay, so you might ask, sir, why we have first one then you can use second one only. Generally what we do is second one we use when figures are higher figures. When figures are small you can use the first one only, but when figures are higher value figures I advise you to use second one. Here how do you get x bar is equal, x bar is nothing but mean. How do you get this summation of x divided by n, average that is. How do you get y bar? Y bar is equal to summation of y divided by n. That is how you will get a y bar. Okay, so remember students, this one is also very important because they might ask MCQs on this. We can use alternative 1, but alternative 2 also they might give you. So remember this. Now let us solve question for first one, that is simple linear regression when we have two variables using the first type only, that is y on x type or x on y type. Because now see students, you might have understood why we have two, y on x or x on y. That depends on which one we are assuming it as x, which one we are assuming it as y. So which one is dependent, which one is independent. So it can change, no. So that is the reason we have two types of equations. Now let us take one example. So please remember this alternative two formulas also. I will solve also MCQs for you. Illustration number 1, this is simple linear regression question. There are two variables that need to be studied. What are those two variables? Is exports of raw cotton and imports of manufactured goods into India. So here the relationship between exports and imports we need to analyze in the form of an equation or regression line. So for that we require past data. No, following data set for 7 years is provided. What kind of regression model should be used here? What kind of regression? So is it simple regression or multilinear regression? So here since we have two variables here, bivariate data here, so we should use simple linear regression only. What kind of regression model should be used here means you should write simple linear regression. What are the results of this regression? Interpret the model estimators. So you need to write what exactly is B, what exactly is A, right? That is called as interpretation. So now I am using which one? Type 1, that is y on x. So what we need to estimate here is which one is x, which one is x, which one is y, you need to estimate here. So let us assume this exports as x and imports as y. What we will do is let x be imports, let x be exports and y as imports. Okay, you can take alternatively also. You can take x as imports, you can take even y as exports. So that is the reason you have two types. Okay, let x be exports and y as imports. Right, now what we require? We require a value and b value to first set the equation. Yes, to get those values, first what we need to do? Take years, then exports, actual figures we need to take, no pass, imports. So this we are taking as x, this we are taking as y. Now what we require for our formula? For our formulas, two equations we need to solve to get A and B. No, these are the two equations. Summation of x is equal to NA plus B summation y. So we require summation x and summation y. Summation x, summation y we can get from these columns. Next one, we require summation of xy also. We require summation of xy. And what else we require? We require y square summation also. We require y square summation. So we require xy and y square summation. We require xy and y square. So these are the columns you should take. Okay, remember what are the equations? Two equations, normal equations. Summation of y is equal to NA plus B summation x. This is the first equation. Other one is summation of xy is equal to so A summation x plus B summation x square. This is another one. No, second one. This is A summation x plus B summation x square. These are the two equations. No, so for this first let us take the values given here. What are those for 7 years? 1, 2, 3, 4, 5, 6, 7. Exports 42, 44, 58, 55, 89, 98, 60. Imports 56, 49, 53, 58, 67, 76, 58. So this is the actual data, my dear students. Now we need to do calculations. So what are the calculations here? Values. Let me use my calculator here. Yes. So what are the values here? First one, x into y, 42 into 56. The value is 2352. Next one is 44 into 49, 2156. Next, 58 into 53 is equal to 3074. Next, 55 into 58 is 3190. Right, next one, 5963, 98 into 76, 7448. 60 into 58, 3480. Now y square. Y square means here 58 square, 3600. 76 square is 9604. 67 square is 7921. 7921. This is 67 square. Next, 58 square, 3025. 3364. So 1936. 1764. So y square I have taken. Now what you need to do is get the totals. So ready figures I am taking, students. So in examination the major challenge is properly calculating these values. Okay. So what is the sum of this x is? Sum of this x is 446. Sum of y is 417. Sum of xy is 27,663. Sum of y square is this summation xy. Summation y, this is summation x. So summation of y square is equal to total 31,214. Right now. So here we assumed let x be the exports and y be the imports. So which one is independent variable and which one is dependent variable here? That is very important. No, we took x as exports and y as imports. So we need to write in our answer also in examination. So let us take we have only one export and one import, two variables only. No, they asked in the question whether we have do you see the please see the question here, what kind of a regression model they asked. No, here if you take one as a dependent variable, naturally other one will become what, independent variable. So since we have only one dependent variable here, we can call it as simple linear regression. So what you can write here is, first one, as there is only one independent variable here, only one independent variable, that is x. It is a simple linear regression. Simple linear regression. Since we have only one independent variable, so x is the independent variable here. Okay. Now the regression equation. What is the regression equation now? The regression equations, how you can write? So summation of y is equal to na plus b summation x. This is the first equation. To calculate the, see, regression equation is capital Y is equal to a plus bx. This is regression equation. Okay. What is y here? Y is the forecasted value. Forecasted value of imports. Capital X is what? Our exports. Later on we have to do that one. Okay. So small y represents actual figure, capital Y represents forecasted value. Students, remember. Okay. Now to solve for a and b, what are the normal equations? Normal equations for calculating a and b value. First one is summation of y is equal to na plus b summation x. This is the first one. Okay. And so what is this? Second one is summation xy is equal to na plus b summation x square. Sorry, a not na, that is for first one. A summation x plus b summation x square. A summation x plus b summation x square here. I told you now how to get this here. This one. You can apply that if you forget that. A summation, this is second y on x on y type. This is first one, a summation x plus b summation x square. Okay, now let us substitute the figures now. Summation of y is equal to how much? 417. 417 is equal to n number of observations is 7. So 7a plus b summation x, how much we got? 446. This is 446. So 446b. 417 is equal to, so what we can, how we can write this equation? 7a plus 446b is equal to 417. Here summation of xy is how much we got? 27,663 is equal to a into summation x. So 446a plus b into summation x square. b into summation x square. We have not done x square, students. We need to take one more figure, one more column here. That is, we have taken we have taken x square only earlier. I took it, I called it as y square there. X square value only this is. So according to our equations, what is required, that only you can take it as columns here. So I wrote it as y, that is not y. I took square for this 42. These figures are for x only. Right. So 1764 is a square of 42. Okay, right. Now substitute b into summation x square, 31,214. 31,214 b this is. So two equations now we are able to get. This is equation number 1, equation number 2. Two equations we got. Now we need to solve these equations. So I told you now, some big numbers if you get, problem becomes little cumbersome. That is the reason you can use second one also for the same question, same answer you will get. Okay, using deviations. Now solve x 1 and 2 here. So 1 has to be cancelled now. So what you do is, now to cancel 1 here, 447a, here you have 446a, 446b. So 31,214 divided by 446. Okay, 69.98 I am getting. Or 446 divided by 7. 20. So what I am doing is, students, we need to cancel one of the variables a or b. So we need to multiply with some figure so that I can cancel. So that's what I am looking for here. So let us do one thing here, multiply with 446 only. If I multiply this with 446, okay, let us multiply with whatever figure only we want. Our first equation is 7a plus 446b is equal to 417. This is the first equation. Second one is 446a plus 31,214b is equal to 27,663. Okay. Now what you do is, this one you multiply with 446. Okay, since we have 446 here, 446 we have now. You multiply with 446. Okay, then what you do is, this you multiply with 7. Okay, let's try this. First equation you multiply with 446, second equation you multiply with 7. So 7 into 446, 3,122 plus 446 into 446. So 1,98,916 B is equal to 1,85,982. This is the first equation. Now second one is 446 into 7 will become 3,122 A only, plus 31,214 into 7 is 2,18,498 B is equal to 27,663 into 7 is 1,93,641, right? So now 1 minus 2, so this will get cancelled. Now this one is 19,582 B is equal to 7,659. This is, so this is 7,659. B is equal to 0.39. So I got B value. Now A is equal to, how to get A now? A is equal to, so 7A, substitute in first, 7A is equal to 417 minus 446 into B, no, 0.39. So 7A is equal to 417 minus 173.94. Okay, so this is 7A is equal to 243.06 and A is equal to 243.06 divided by 7, you are getting 34.72. So we got A value and B value, my dear students. So now what is the regression equation? Therefore the regression only equation we got, first regression equation is capital Y is equal to, this is required for forecasting now, Y is equal to small a 34.72 plus B is 0.39 capital X. Now based on X values I can get the Y values. So this is a regression equation. So what they asked, regression equation as they asked, results of this regression, interpret the model estimators also. So we need to give interpretation of what is the meaning of B and then A, right? So interpretations. So B represents slope. B is called as the slope of regression. B is equal to slope of the regression equation. Slope of the regression equation, which indicates, what does it indicate? What is the change in Y value with respect to change in X value? Slope of regression equation, which indicates change in Y due to change in X. Change in Y due to change in X, that is in our question change in imports due to change in exports. This is what we can calculate. Once you know B value, then we can calculate the forecasted figures. Next, what is A here? A is equal to intercept, it is called as intercept of Y, intercept of Y on x-axis, when x is equal to 0, So what is the meaning of that? When there is, what is the meaning? How do you interpret this? When x is equal to x is nothing but exports. Now we assumed when exports are 0, then what will be our imports? That is when there is no exports. When there is no exports, the value of imports will be 34.72. Alright. So slope, I hope you understood what is the meaning, interpretation of slope. So slope of the regression equation indicates what is the change in y value with respect to change in x value. And what does A represents? It represents the intercept. That is when x value is equal to 0. Okay. Yes. That line intercepts. Already I told you here. This is the diagrammatic representation here. So this is called as A. When this is 0, x is equal to 0. Okay, this is called as the intercept. Interpretation also they will ask you to write in the exam. So this is simple linear regression, my dear students. Okay, I told you that another alternative is also there now. What you can do, you can use this formula also. That is, you require xy, x square. Already we know those figures. Xy we know, x square also. From that you calculate by x. Then calculate y minus y bar, x minus x bar. Or you can do one more thing. Now see, from this same question already we calculated xy, x square also we calculated, no? Now only thing what you require is correlation you require again. So correlation, how to calculate correlation, that is also very important. So correlation formula is also required here. Correlation formula R is equal to covariance between x and y divided by standard deviation of x into standard deviation of y. This is the formula. Okay, so in the question sometimes they will directly give you correlation. So again to use this you require R. So better you use first alternative only whenever they have asked in the exam. Better you use these normal equations only to get A value and B value. Unless they give you directly R value, correlation value, you can use that formula. So I will show you that scenario questions here. I hope everyone understood this question. Now these alternative questions. Alternative 2 also is there, no? So I will show you questions in CMA material. MCQs they have asked. You can see here, students. You can see this question number 27 and 28. Based on alternative 2, you can do these questions. For a bivariate data set, that is x comma y, only two variables. If the means, standard deviation and correlation coefficient are respectively x bar is equal to 1. So mean of x is 1, mean of y is 2, standard deviation of x is 3, standard deviation of y is 9, and correlation between x and y is 0.8. The regression line y on x is, they are asking what is the regression line y on x. I told you know what is the regression line y on x. This y is equal to a plus bx can be written as y minus y bar is equal to by on x into x minus x bar, no? This is how you can write. And how to calculate by on x is equal to correlation between x and y into standard deviation of y divided by standard deviation of x. So here have they given correlation? Yes, 0.8. 0.8 into what is the standard deviation of y? 9 divided by what is the standard deviation of x? 3. So this is 2.4. So I calculate b y x. Okay, what else they have given? X bar they have given. So y minus what is the y bar? 2 is equal to byx is how much? 2.4 into x minus what is x bar? 1. So y is equal to 2 goes that side, plus 2. Okay, plus 2.4 into x minus 1. So our answer is C. So understood. So they might give you MCQs where you can use this alternative too. Students, the concept behind this is the same regression line only. Alright, even if you use this also, we'll get same answer. Answer will not change. Only approach is changing. Remember that. So this is called as using the deviations. Deviation formula this is. So same y is equal to a plus bx. Statistically we can measure like this. Next 28 question also, using alternative 2 only you can do here. The data about sales and advertisement expenditure of a firm is given below. The data about sales and advertisement expenditure of a firm is given below. So sales given, advertisement is given. Now in this we have to assume which one is x and which one is y. So let's assume now. Let's read the question. We might get some hints also. The correlation coefficient between sales and advertisement expenditure is 0.9. Correlation is given between sales and advertisement. The likely sales for a proposed advertisement expenditure of 10 crores is. So if advertisement expenditure is 10 crores, then what is the sales they are asking? Okay. So here sales is a dependent variable and advertisement is independent variable. So what I will do is advertisement I will take it as x. Sales I will take it as y. Okay. Now what is given here? They have given a mean. Mean is nothing but this is y bar they have given. X bar is also given. Standard deviation of y, this is standard deviation of x, it will become. Now correlation coefficient is also given. The likely sales. So if you want to forecast the sales value for advertisement expenditure, first you should get the equation. No. So y on x is equal to this can y is equal to a plus bx. No. A plus bx, or y minus y bar is equal to byx into x minus x bar, because the data is given in that manner, not so that directly we can use the second one only here. So in this byy by byx is equal to correlation between these two, how much? 0.9 into what is standard deviation of y? Sales we are assuming it as y, no? So 40 divided by, sorry, not 40, 10 divided by what is the standard deviation of x? 1.5. So what is your byx is equal to 0.9 into 10 divided by 1.5. 6 I am getting. Okay, and mean also we have now. So y is equal to y minus y bar is how much? Mean of y 40. Byx value 6 into x minus x bar is how much? X mean is 6. If you solve this, you will get the equation, regression line you will get first. So y minus 40 is equal to 6x minus 36. So y is equal to 40 minus 36, 40 if it comes to this way, plus 40, 40 minus 36, 4. So 4 plus 6x, this is the regression line. So first you should get regression line using this. So y is equal to 4 plus 6x I got. Now I want to calculate y value. If proposed advertisement expenditure is 10 crores, if x is equal to 10, how much is y? So y is equal to 4 plus 6 into what is advertisement expenditure? 10. So 6 into 10, 60 plus 4, 64. So 64 is the answer. So what is the likely sales if advertisement expenditure is 10 crores? It is 64. So they might ask you in MCQs, my dear students. So 28 answer is A. The 28 answer is A. So these two are MCQs are very important, students. Even see, even this equations, again this one, correlation between x and y is they are asking 30. Okay, what they have given, 4x plus 3y plus 7 is equal to 0, 3x plus 4y plus 8 is equal to 0. So they are giving regression lines, correlation they are asking here. So how we can get correlation between x and y? So if you solve this, first of all, what you will get? So 4x plus 3y is equal to minus 7. 3x plus 4y is equal to minus 8. Okay, you multiply this with 3, this one with 4. So then 12x plus 12y is equal to minus 21. This one is 12x plus 16y is equal to minus 32. So minus minus, this one make a plus, cancel this one. So minus 4y is equal to minus only we are doing, no? Yes. So minus 21 plus 30 minus into minus plus, no? So 32 means 32 minus 21 here. So 9 minus, no, positive 9 only. Plus 32 will become, no. So y is equal to 9 minus 9 by 4. 9 by 4 is 2.25 you are getting. Y is equal to minus 2.25 you are getting. So I got a y value here. Basically y value is like our b value only. So minus 2.25 we got. If you substitute in this equation, what x we will get? X is equal to, so 4x plus 3y, 3 into minus 2.25 is equal to minus 7. So 4x minus 3 into 2.25 is equal to minus 6.75 is equal to minus 7. So 4x is equal to minus 0.25. Yeah, x is equal to minus 0.25 divided by 4, minus 0.0625 we are getting. So I got x value and y value, the coefficient of correlation between x and y. For this correlation, I told you, we require, what we can do is we can substitute in this equation. To substitute in this equation, we require remaining, no. So we got both x value and y value, the coefficient of correlation between x and y. The formula is covariance between these two, but covariance you cannot calculate here. X value, y value we got. So to apply coefficient of correlation formula, we don't have that data here to take average. These are two regression lines. This is one regression line, this one regression line. Okay. X is like A and Y is like B, no? So literally here Y is like B. 4x plus 3y is equal to two lines of regression. So what is the correlation between these two? So x we got, y we got. Okay, anyhow, so let me solve that, students. Right, towards the end again I'll solve it and I will explain that. It is killing little time now. So towards the end I will give you the answer for that after solving that. Now quickly we will move to other one. What is that is single linear regression we covered. Now we will move to multiple linear regression. We completed simple linear regression. We have another question also on this. That is this one, illustration number 2. It is also your institute material question only. They have given towards the end. So watch this carefully, students. Illustration number 2. This I would like to explain here. This is part of your material only. This one I will show you now in your CMA institute material. They have given part of your questions. This is the question, that is question number 5 in your institute material. While calculating the coefficient of correlation between two variables x and y, the following results were obtained. N is equal to 25, summation of x is equal to 125, summation of y is equal to 100, summation of x square is equal to 650, summation of y square is equal to 460, summation of xy is equal to 508. It was however discovered later on that two pairs of observations x comma y were copied as 614 and 86 instead of 812 and 68 respectively. Determine the correct equations of two regression lines. Correct equations of two regression lines, that is y on x and x on y. So they are giving you regression lines. What they are giving you? They are giving you regression lines. From two regression lines, we have to calculate those. We have to present those two regression lines here. If you see what is the mistake they have committed here is, instead of taking 8, 12 and 6, 8, they took it as 6, 14 and 8, 6. Two pair of observations x, y were copied as 6, 14 and 8, 6 instead of 8, 12 and 6, 8. So what we are supposed to do here? Okay, for our calculations, is it first of all SLR only? Yes, because we have bivariate data now here, x and y. So how we can correct that is, now see x 6, 14, these are the wrong numbers they have taken, no, 8, 6. So this is xy, this is xy. What they are supposed to take actually 8, 12, 6, 8. So this they should have taken, but they have taken this. So remove the wrong ones, add the correct ones in the respective calculations. For example, now summation of x, they have given 125 now. How you can make adjustment is, wrong x values you remove. It is summation of x values only, no. Individual x value only you added, no. So what you do is, from this You remove wrong ones, include the correct ones. What are the wrong x values here? Minus 6, minus 8. Take the correct one. What are the correct one? 8, 6 plus 8. X values only, no? They took 6, 14 and 8, 6 instead of 8, 12 and 6, 8. So x value is 8. Wrong one is 6, 8. Minus 6, minus 8. Correct one is plus 8, plus 6. So ultimately it is 125 only. Summation of x. Then summation of y is equal to 100. Same again, same adjustment. Summation of y again. What is the wrong one they have taken? Remove it. Minus 14, minus 6. Correct ones plus 12, plus 8. So same effect again, 100 only, because minus 14, minus 6, minus 20 is plus 20. So 100 only. Then what is the effect on x square? So 650, what you do is minus 6 square minus 8 square plus 8 square plus 6 square. This is what you are supposed to get. Next, get the values, correct value for that. Ultimately it is same only, you will get 650 only here. Then what about summation of y square? Summation of y square is equal to 460 minus 14 square minus 6 square plus 12 square plus 8 square. This one will change. Minus 14 square minus 6 square plus 12 square plus 8 square, no. So yes, that value should get. Then another one is summation of xy. X into y, no, this is x into y. So what is the figure they have given? Wrong figure, that is 508. So what adjustment we will do is x into y they have done, no. So this is one pair, this is one pair. So 6 into what we have to do is minus 6 into 14 minus 8 into 6 plus 8 into 12 plus 6 into 8. This is what you should do. How do you get summation of xy is x into y we multiply, no. So wrong pairs you multiply and deduct it. Correct pairs you add it. Multiply and add it. This is what you are supposed to do. I hope you understood, students. Yes. Once you get the correct values, then what you can do? You can take the normal equations. What are the normal equations? Let me show you now. I have solved it here. So first is we need to get two equations. They ask two regression, y on x type and x on y type. So y is equal to a plus bx. To obtain values of a and b, two normal equations are to be solved. What are those two normal equations? Summation of y is equal to na plus b summation x. Other one is summation of xy is equal to a summation x plus b summation x square. Now substitute the figures now already. Summation of y already we got here. What is the summation of y? 100. Summation of y is 100 only. No change. Summation of next 25. What is n value here? N is equal to number of observations. N is equal to 25. NA, no. So 25A plus 25A plus B into summation of x is same 125 only. Yes, students. So now we are substituting those figures now. Summation x is 125 only. So b summation x 125. 125b. Next. Summation of xy is also no change, 520. Summation of xy what we got? So this we did not calculate. I will write for you here summation of what are the values of this. I will write here for you so that when I share the document it will be useful. So given n is equal to 25 here. Okay, next summation x, how do you get? Summation x is equal to 125 minus 6 minus 8 plus 8 plus 6. So value remains same, 125. Then summation y is equal to 100. What are the y figures here? 14. Wrongly they have taken this one. So 6 part 6 8 over x values. Now y values minus 14 minus 6. Correct y values are here 12 plus 8. Ultimately 21 in the figure. So 100. Next, summation of x square. So 125 x square value is how much? 650, not 125, 650. 650 minus 6 square minus 8 square plus 8 square plus 6 square. It is 650 only. Summation of y square is equal to 460 minus 14 square minus 6 square plus 12 square plus 8 square. The value of this is this value will change, students. 436 it will be. Then one more is xy. What is xy? 508. Wrong figure. Minus, now what we need to do is x into y now. So first wrong figure, 6 into 14 they might have added, 8 into 6 also they might have added. So first 6 into 14 minus 8 into 6 plus 8 into 12 plus 6 into 8. This is what you are supposed to do. Now this value is 520. So once you correct this, okay, then now what you can do is get the values of a and b using the normal equations. Then you can form the two regression lines. This is what you are supposed to do. So that is a question, students. So this is a very important one for this upcoming attempt. Important for this upcoming attempt here. Important for December 25. Now we need to take the equations, normal equations. Summation of y is equal to na plus b summation x. So I substitute in that. 100 is equal to 25a plus 125b. So after solving that, a is equal to 0, I got b is equal to 0.8. So this is the equation, regression equation, y on x. So y is equal to 0.8x. This is the first one, y on x type. Now second one is x on y type. I gave you equations now again. This is x is equal to a plus by. X on y type. To obtain values of a and b, solve simple equations. These are the equations now again. Now x is equal to a plus by now, y. Summation you apply on both sides, then multiply with, this time you should multiply with y because the input variable is, independent variable is y here. Here when you are multiplying here with y, you should multiply. So here only summation, no. First equation with summation, second equation first multiply with y, then summation. That is how you get this equation. Summation x is equal to na plus b summation y. Summation xy is equal to a summation y plus b summation y square. X on y type. Again take the same figures, values. Substitute in these normal equations, solve for a and b value you get. Then again x on y type you got. Simple. So refer to this question also, important one. These two illustrations will help you, practice them. So this is your single linear regression question, my dear students. Okay, one more video I will cover multiple linear regression, and along with that I will cover time series also. Okay, thank you. Forgot to cover now this last MCQ I was covering now. So that I will share it in part 2. In part 2 I will share the answer. I will solve it. I will give you that. So if you see that MCQ, they have given directly equations, the final regression lines they have given. Reverse we have to calculate, regression lines they have given. From regression lines we have to calculate the correlation coefficient. Okay, in part 2 I will give the answer for those MCQs also. Thank you.